And now that we have defined the state space of Simple Bank and all the constraints of the state space, which are captured by the requirements R4, R5, and R6, and it is now time to define the dynamics of this system, which means I will have to define the operations for this system. And these are requirements R7 to R11. And so the first requirement that I will tackle is R9. We want our bank system to enable deposits and withdrawals from bank accounts, to and from bank accounts. So let's go back to our model. And so this basically defines our state space, right? But now we need to double click here on Bank VCLBD, and here we will start defining the dynamics or the behavior of the system. And so I will start by saying that I will need some local definitions, some local units of behavior for the class set account. And I will define an update operation called deposit. And I will have to say that this deposit operation is an update operation. It updates or modifies the state of the account object. And now if I double click it, I will start defining it. And as the assertion diagram, the contract diagram is slightly different because we have two compartments. We have a declarations compartment and then the precondition on the left and the post condition on the right. So on the declarations, I will start defining the inputs to this operation. And what I will really need is an amount input. So I will have an amount of type nat, which is a natural number. And now I don't really have a precondition for deposit locally. So any amount will be deposited onto the bank's account. But I will have obviously a post condition. And really what changes here is, I will say it on the post condition side, what really changes is the balance of the account, or the BAL, which becomes the new BAL, which is here in bold, which becomes equal to, becomes the old BAL plus the amount. And there we go. We've got, and this is basically saying what the local contract for deposit. I get an amount, and for a particular object, in the state of a particular object, and I update the balance state, the balance field, the balance component, to say that the balance is the old balance plus this amount. Okay. And now I can also define withdraw, because the withdraw will be really similar. Okay. I again have to say that it's an update operation. And here I can use a trick, because I'm going to cut and paste from the previous one. So account deposit is here on the left hand side on the package explorer. The account deposit is the deposit operation that we just defined. So I'm going to do Control C, Control V, and I'm going to call this account withdraw. Okay, which will be the one for the withdraw operation. And now if I double click it, it's here, the withdraw, but now I need to just modify the post condition. So that the post condition in the case of withdraw is really balance minus amount. Well, and this defines the local operations for deposit and withdraw on the account class. But now I need to define is the global behavior of these operations. So I will start with an ACC deposit. And and this will define the global operation. And so what happens here is that I assume that on a particular account object I do this. Okay. But globally, what I need to do is to find the object. What I need is to find the right object and then perform the operation on that particular object. So he asks me if I want to create a contract diagram for deposit. I will say yes. And I will enlarge it a little bit. And so first I need to define is my inputs for this operation. And what happens is that I will have an amount which is of type NOT, which is the same, which corresponds to the amount input that I defined in my local contract. And I've got also a account number. So a no question mark, which is account ID. And now what I have to do is I need to do an operation that basically will get my account object given this account number. So I'm going to define this as an observe operation, which is an assertion defined here, and I will call this a grab. Grab account given account number. Okay, I will turn the imports off. And so I need to now to define this grab. And this grab will take as an input, like I had previously, a no question mark of account identifiers, account ID. Let's see if my name is correct. No, it's account no. Actually, I'm going to put this here so that it's type checked. So it's called grab account given account number. And there we go. So we've got an account. This is an account number also. And there we go. So we've got the account number as an input. And I'm going to define also an output, which is the account that is going to be obtained from this, A of type account. And now the way that I'm going to express this is as an arrows formula. I will say that my account output will belong to the set of accounts, okay, to the set of accounts whose number is this one, okay. So I will define this as a formula, not a formula set def. Here I will define as a set expression and a set definition with an arrows formula. I will get the set of all accounts whose account number is my account number input. And there we go. It gives me all the accounts whose account number is my account number input. And what it happens is, because I have that invariant that says that account numbers are unique, this means that this set is at most a singleton. And therefore, when I have A belongs to a singleton, I've got A is equal to the element that is inside. And if there is no element, then this is false, and there is no account corresponding to that account number, which is fine. And so, yeah, basically this defines my grab operation. It grabs my account object given that account number identifier, which is meaningful in the outside world, in the environment. But here, when I come to the world of objects, I need to do this to get the number and obtain the corresponding object in my system of objects that I have defined here. And so, yes, here we go. I grabbed my object, and which is defined in this object is defined as an A exclamation mark. And now what I need is really to to define a deposit, to call the local deposit on this A exclamation mark. So, and I simply call deposit on it, okay, with the import set to true, yeah. And if it's set to true, I don't need this amount here. Yes, I simply call my deposit here, and this calls the deposit operation. Yeah, and for deposit we're done, basically. And now we can try and do the same, so I don't need this in anymore. We can try and do the same is for the ACC withdraw, which I can simply define by cutting and paste the ACC deposit. And now if I double click here, now instead of calling the deposit, what I need really to do is to call the withdraw. And this defines my contract withdraw. And yes, I am done.